Hello, and welcome to this episode of Casual Endeavors. Today I'll be trying something new for myself. I will be attempting to use a laser to pass UART messages between microcontrollers. I have never used UART before, and my experience with lasers is largely restricted to detecting and driving atomic force microscopy cantilevers for the purposes of testing modified Newtonian dynamics in an Earth-based laboratory. So, not really related to this. The two microcontrollers I will be using are an Arduino Uno and a Teensy 4.1, which I just got a couple weeks ago. The laser, photodiode, and accelerometer comes from an Elegoo kit I bought off Amazon. I also require an operational amplifier, or op-amp, and a potentiometer that we're just kicking around. This project used 4 pieces of software. We start on my desktop with Pi Server, which allows the user to send commands to the Arduino and receive confirmational messages. UART Server runs on the Arduino and accepts commands from the PC. The Arduino passes commands and data to the Teensy via UART. The Arduino can tell the Teensy to turn its LED on or off, just a basic test, and send data collected from an accelerometer to the Teensy. The data is just to see how reliable data transfer is when there is a larger amount to pass. UART Client runs on the Teensy and processes commands from the Arduino and passes messages and data back to the PC. Finally, Pi Client runs on the PC and simply displays the information that is received from the Teensy. It should be noted that Pi Server and Pi Client both run on the same PC, but they are running in different terminals and are wholly independent of each other. The data flow goes from Pi Server to the Arduino, to the Teensy, and then to Pi Client. Just to ensure that the components and code is working correctly, let's do a quick test using hardwired connections. There is a third wire here. This is just connecting the grounds of the two microcontrollers, and the data is transferred along these 2 wires. So, we set the Teensy's LED on, off, transfer some data. Perfect. That's how this should work. Let's do a quick experiment to see how this laser and photodiode setup is going to work. I have a function in the Arduino and Teensy code that hasn't been used yet. This allows the Arduino to turn the laser on and off every half second, and the Teensy to constantly report an analog measurement. The laser signal will be connected to the Arduino's pin 12, and the photodetector will be connected to the Teensy's pin A0. Now we can test to see how the photodiode will respond to incoming light. When the laser is on, the photodiode outputs a low signal, and when the laser is off, the photodiode outputs a high signal. This is the exact opposite of what we want. Not a problem, we just need a NOT gate in the circuit. This is where the op-amp comes into play. I'm going to set it up as an inverting comparator circuit and use a potentiometer to create a threshold voltage. I'm going to connect 3.3 volts to this pin and ground to this pin. The potentiometer will act as a voltage divider, and the center pin will output a voltage that is between 0 and 3.3 volts, depending on the value the potentiometer is set to. This is the threshold voltage. It should be less than the voltage output by the photodiode when the laser is turned off, but more than the photodiode's voltage when the laser is on. Anywhere in this region should be fine. The inverting comparator circuit will output high if the signal from the photodiode is less than the threshold voltage, and low if the photodiode signal is greater. I don't expect this to work particularly well, so I'm going to drop the baud rate down a bit, to 8. First test, LED on, LED off. Good. Now for some data. Looks good. Slow, but good. I think it's neat that it's running so slow you can actually see the laser turning on and off. Time to increase the baud rate. The highest I've been able to get it to work is 330. Bear in mind the default is 9600 and a 56K modem is around 8000. According to Wikipedia, 300 baud was achieved in 1962, so get ready to feel groovy. All in, I think this was a great project. Some new things, some problem solving, lasers, how could it not be? Anyways, thanks for checking out this project.